my name is Christophe Lepage and I'm going to demonstrate the Radi model. So first I click on Core Mass and as usual I go to Tools of the main VisualWorks interface and go down to select Core Mass English. Then I have this Core Mass main interface. In the File menu I go for Load from ST and I scroll down till I can find the Radi model. Okay, I will pick this version, Radi 2006 Autonomous, open. Okay. To simulate this model, I go to Simulation and I open the simulation interface. That's it. Click on Initialize and select Init and Step method, apply and close. We'll have a look to the spatial grid of this model. In Visualization, I click on Space. Enlarge a little bit the space. So this is representing the game board of the Radi game. We have 24 cells and 4 colors. The white color indicates no resource level. The light blue indicates low level of resource. The dark blue indicates medium level of resource. And finally, the green one indicates high level of resource. So this is the initial situation in the game board. And during the game, the 10 players will have to locate their 5 animals somewhere on that grid. If I click on Step, you'll see that you have some diamonds, you have some circles. The circles are representing the yak of the Merak players. Each player has 5 animals, like for the yellow player, 1, 2, 3, 4, and the 5th one somewhere else. Here, represent the 5 animals of that player. And for diamonds, let's have a look to the red one. There are also 5 red diamonds located somewhere, representing the 5 animals of that Radi player. So in this autonomous version of the model, the animals have been located randomly, independently, one from another, in any cells with some resource. So everywhere except in the white one. And as for the regeneration rules of the resource, they are quite simple. There is a carrying capacity of the cell that is related to the level of resource. For the light blue, the carrying capacity is 2 animals. Above that level, the resource will remain the same. If it's more than the carrying capacity, then the resource is degraded such that in the next step, the value will be decreased by 1. For instance, if we look to cell number 18, there are 1, 2, 3, 4 animals located there. It's above carrying capacity that is set to 2 for that level. So next time, this cell will appear in white, the level below. As for cell number 9, there is only 1 animal, which is below the carrying capacity for that level. So next time, it will remain the same color. For the dark blue, the carrying capacity is set to 4. In cell number 2, 1, 2, 3, 4, 5 animals. It means next time it will be degraded to light blue. It won't be the case for cell number 1 because there is only 1 animal there. And for the green cell, the carrying capacity is set to 6 animals. So it means here we have 1, 2, 3, 4, 5 animals. It will remain the same for round number 2. If I click on Step, this is what happened. Okay, now we have a little bit more white cells. Some cells have been regenerated. It's happening with 50% of change in cells with no animal at all. Let's move to the next step. Because the animals are located randomly somewhere with some resource, obviously we don't have any animals in all the white cells. And again, the distribution of all the animals have been decided by the computer randomly. Same rules will apply, like for instance in cells 21 and 6, the resource will remain the same because number of animals is below the carrying capacity, while in cell number 8 and 9, because the number of animals is above the carrying capacity, they will be degraded next time. This is what happened. And I can click on that until we reach step number 5. And this is the final state. As you can see, the majority of cells is now white, meaning globally the resource has decreased. This was a demonstration of the autonomous version of Radi model.